Hello. Today we are going to work on something more funny. This is the Gateway Arch by saarinen, built during 1947 and 1975 at Saarinen. To draw this geometry, we need to use a specific geometry, that is the catenary. As you can see, this curve is not a parabola, it's a specific shape that you can see when a cord or a chain bend due to gravity force. Grasshopper has a specific component to manage this kind of geometry, that is catenary. Catenary needs a point A, a starting point, an ending point, a length parameter, and the gravity direction as a vector. The gravity vector is needed because this geometry can be used in several directions, natural direction or reverse direction, that is this method used by Gaudí for the Sagrada Familia design. Now we generate the 2 points, the starting point and the end point. The first point can be at 0, 0, 0. The second point, we use a slider with 100 as value for the x coordinate of the second point. Let's connect the 2 points, the first one to the A parameter, the second one to the B parameter. Now we need another slider for the curve length. 200 will be okay. As you can see, the catenary point to the bottom. So we need to change the vector, type Z to obtain the Z unary vector that point to the top. And as you can see, now we have the right arch. You can find catenary under curve, spline, catenary. Now we should increase the curve length to obtain a more realistic geometry. Now to proceed, we have to generate the cross section of the arch, that is a triangle, as you can see in this picture. So we need a polygon component, that you can find it in curve primitive polygon. By default, polygon is set with 6 sides, 6 segments. To set the segment, you need just a slider with number 3 as value. The radius parameter is the radius of the circumscribed circle, that is the circle around the triangle, obviously. We need to increase this parameter to have a bigger triangle. The base plane is by default the word XY, and it's okay for us now. The fillet radius is to have round corner, but we can leave it as 0. A radius of 6 would be okay. And now we can use a sweep one rail. You can find it under Surface, Freeform, Sweep 1. And this component needs a rail, that is our catenary, and a cross-section, or a series of cross-section, that for now is our triangle. So connect the catenary to the rail and the triangle with the section. As you can see, the geometry is not continuous, but has several segments. And this happens because the catenary is indeed not a continuous curve. And we can check it. We can see what's going on here with the component discontinuity. You can find it under Curve Analysis Discontinuity. That is the one with these two arrows, the green one and the red one. Connect the catenary to discontinuity, and as you can see, we have several discontinuity points along the curve, because the catenary is set as a series of segments by default. So we need to rebuild this curve as an interpolate curve. You can find interpolate under Curve, Spline, Interpolate Curve. And we can use the discontinuity point as vertices for the interpolate curve component, so to have a continuous curve that approximates the original catenary. Substitute the new curve to the catenary, and as you can see, now the sweep geometry is continuous. But we have an issue. If we go to the front view and see the right part of this geometry, you can see that the final section, the end section, is not parallel to the XY plane. It follows the curve, but it's not parallel to XY. If we connect the new curve, you can find this component perp frames under curve division perp frames. If we connect the perp frames to the interpolate curve, we should see a series of planes perpendicular to the curve step by step. And indeed, also the last plane is not parallel to xy. So the problem is that the cross section, align to the tangent of this curve step by step. So we need to force the sweep geometry to end with a parallel triangular section. So turn off the preview for the sweep geometry. Now that we have several components on the canvas, I can explain you how to organize an algorithm to make it more tidy. Obviously you can freely move the components around, but there is an easy way to align them. For example, select these first elements. As you can see, around these elements some handles appear with buttons to align, for example, the center, to have equal spaces between elements, to align to the right or to the left, or for example to align to the center. And in the same way to have horizontal equal spaces between elements. So for now we can choose align to the right. For these two elements we can choose to align to the top. For these two, the catenary and the polygon, align to the center, and so on. Here align to the top. And also for these two sliders we can align and have equal spaces. And in this case align to the top. And now we have absolutely more tidy. There is also a way to group components. To it, select components on canvas. Then you can use the keyboard combination Ctrl+G, or click the mouse wheel and then select group. As you can see, the elements